All right, so let's finish that bit of algebra we were working on for the price floor. I just drew myself a really, barroom napkin diagram just to keep myself on track here. So we found our equilibrium quantity, where quantity supplied equals quantity demanded. We did that by rearranging our functions to be in terms of price. Now, what we need to figure out is what happens to our quantity, right? So our delta quantity, delta Q, is going to be dA minus BC over D minus B, our equilibrium quantity, minus the quantity we end up with, which is going to be where we hit the demand curve, which is going to be A plus B times PF for our price floor. Cool. That's delta Q, and there we're just going to plug in some value for the price floor. What's next? We need to find the gap. And for that gap, what we need to do is say this quantity, right, this is QF. We need to plug this quantity into the supply curve. So this quantity into the supply curve and find the price. Here it's nice that we've already rearranged this. So this is our price on the supply curve is going to be QF minus C over D, where QF is A plus B times PF, and then just minus C all over D, right? Not too bad. Now, let's take this, and I'm going to plug it into a spreadsheet. So we'll say A, B, C, D. We'll make up a model off the top of our head. We'll find our Q star. We'll find our QF. Actually, I guess we should say, we'll figure out P star, and then we'll put in a PF. We'll do the price floor. Oh, sorry. Let me share my screen. There we go. I haven't set up yet. So A, this is the top of our demand curve. Let's call it 100. B is going to be, let's say, -1. C, let's make it 10. And D, we'll make it +1. Just throwing numbers into here. So Q is going to be some stuff over some other stuff. I'm going to sort out my parentheses first, just so that it all works. We want D times A minus B times C all over D minus B. There's Q star. F star, we can just plug into either supply or demand. So let's do the supply curve. That's C plus D times Q star. We've got price. So let's make a price floor of, let's say, 50. Then we want to know what is our quantity given that price floor. The relevant point is going to be the demand curve. So that will be A plus B times our price floor. There is our quantity. So let's say -2, +3, right? Whatever the case may be. 0, that doesn't seem right. Oh, that's just, make this 150. Yeah. So we can plug in different numbers. It's updating automatically. Right, whatever numbers we put in here should work out all right. It's kind of weird that we're getting 50 and 50, and it's just a little oddly symmetrical, but we're not going to sweat it. We got our price floor that we are putting in manually. That is solving for the quantity that we get. And then we need the price on the supply curve. which is going to be C plus D times, oh, whoops, I got that wrong. I was looking at the wrong format. It's going to be the quantity minus C all over D. So our price in this case is 13.3. Let's go ahead and see both at the same time. So given these numbers, if we've got 100, a slope of -1, supply intercept of 10, a slope of +3, that's going to be relatively steep. We throw in, we throw that all together, we find an equilibrium quantity of 77.5, a price of 242.5, and then we dramatically lower that price to 50. Our quantity drops not that much, a surprisingly small amount, but where we are on the supply curve, 13.33 is a pretty small number compared to that price ceiling, that price floor of 50. Oh, you know what? This is a non-binding price floor. Let's make this 250. There we go. That makes a little bit more sense. Now we did throw this off a little bit. Let's make these numbers a little bit more sensible. This is the difficulty of making up numbers off the top of your head. This is part of the reason, one of many reasons that I like to use these symbols instead of specific numbers, is coming up with an example of specific numbers really takes a lot more effort. So we plug this all in, it's all updating automatically. We do want to make sure that our price floor is binding, which means it's less than our equilibrium price. But given this made-up market, we've got our equilibrium, we've got our prices, our price floor we're imposing, we're finding what quantity do we get against the demand curve. We trace that quantity down to the supply curve and we find the price that corresponds with that. That gives us a gap here, and then we can find our dead weight loss. Our dead weight loss in this case is going to be the change in quantity times that gap in price divided by 2. Right, so dead weight loss of 25 for this hypothetical. Right, that would correspond with the area of this green triangle, where we're still holding all else equal. We're not breaking the ceteris paribus assumption. Given this model that I just made up off the top of my head with very creative numbers, we've got something that will automatically update for us. And you can take this spreadsheet and you can plug in any model you want, and it will automatically give you the right stuff. Now, there is that caveat, which is that if you say put in $70, it's going to assume that just because you've got a price floor over here, that you're still getting this quantity demanded, which is, of course, not very reasonable. It's up to us as the human being in this equation to interpret things sensibly, to double-check stuff. Right? So we might also ask, is this price floor less than our equilibrium price? And if it's false, then we should just say, let's ignore this. Right? So our dead weight loss should be equals, if we do have a binding price floor, then it's going to be this. Otherwise, it's going to be 0. And this, likewise, we can say equals, if we have a binding price floor, then this is going to be the price that's supplied. Otherwise, we will just have the equilibrium price. And then equals, if we have a binding price floor, then our quantity given that price floor will be what we calculated before. Otherwise, it will be the equilibrium quantity. And so now we can throw things in like, say, well, if we have a price floor of 70 relative to, Oh, did I get this wrong? This should be our price floor is greater than our equilibrium price. So here we have a binding price floor, and the result is we get 625 of deadweight loss. All right, so given all of this setup, this is calculating stuff for us automatically. And then if we change this price floor to, say, 0, well, a legal minimum price of 0 is not a binding price floor, so there's no deadweight loss. Right? If I say car companies can't sell cars for less than $0, well, then a car is still going to cost $20,000 or $30,000. So that is the price floor in a spreadsheet. It's going to be very similar for a price ceiling, but I'll leave that to you to figure out. So with this, you can just plug in the numbers that we've got in here, not the quadratic, but the linear. You can plug in any models you want, and it should give you the right answers. All right, so if you've got any questions about that, reach out, feel free, talk amongst yourselves, play around with it in your study groups, and I will talk to you in the future.